So next, I would call Mr. Nikhil Bhamare on stage. He is there with us today at IIT Bombay. He is the founder of the startup CFD Baba. So over to you, sir.
Hello everyone, I am Nikhil Bhamre and today I will be talking on OpenFOAM beyond academia. That means what will you do after learning OpenFOAM and how to go for industrial applications. So for today's discussion, the flow will be that we will first discuss a little bit about myself and my first OpenFOAM problem. Then we'll discuss for the student skills required for industry and what students can do after learning those skills. And we'll go towards the closure of PPT, and if time permits, I'll show one small case study which is quite interesting. So I started with CFD Baba channel in 2019, and in 2023 I was suddenly ranking among the top CFD creators worldwide, and then people keep giving my reference as an influencer. So these photos were posted by Simon Fisher, who is at rank 11th himself, and I am very privileged to be among all the top CFD creators all over the globe. But my main interest is to promote OpenFOAM right now to the Indian students. So my first CFD problem, I did it when I was in Suzlon One Earth. It is a windmill company. So the project was thermal housekeeping of wind turbine nacelle using OpenFOAM. So I went to the company. They said in 2018 the company was not too good at that time in terms of financial status. So they said they don't have money for license. You need to do it in OpenFOAM. So I did my MTech project using this same problem. So here you can see this problem. It had two fans as inlet, two fans as outlet at the top, and there were heat generating components. So what is this nacelle? If you have observed wind turbine closely, you will see that behind the wind turbine blades there is a box like structure. That is called nacelle. Inside nacelle, this shaft is connected to the wind turbine blades. Then there is a gearbox, and then the mechanical energy is transferred through the coupling to generator and then converted to electric energy and sent down through the tall towers on which the windmills stand. So in this problem, there were many models together. So every time you go to solve industry problem, you will rarely find a single model problem. You will have to use multiple models in your problem. So in this case, I had to simulate fans with fan curve inputs. Then there were volumetric heat sources for gearbox coupling generator. Of course, there was turbulent flow heat transfer going on. And at the bottom opening, there was porous medium. So all these together in 2018 was quite rough, I must say. So I started with learning the mesh first. So I remember the first day when I meshed this CAD model, which is 3D, very complex inside, and it was quite happy moment for me, and things didn't stop after that. So the problem was that this coupling here was exceeding the acceptable limit of temperature, and they wanted a solution, quick solution, without spending much money on how we can increase the cooling of this fluid coupling. So the solution I proposed was that we can extend the length of fan 4 duct and we can increase the speed of the fan slightly. So as you can see in this velocity contour plot, the air is now moving into the duct, and here in the temperature plot We can see cold air coming in from backside, taking the heat from generator fluid coupling, successfully going out through the duct. Earlier it was not happening because duct was very small, fan was very slow. So this is how I solved my first OpenFOAM problem after lots and lots of struggle. But I had time at that time since I was in masters. But then I realized that there are no sources which can help Indian students to solve complex industrial problems. There were sources to solve simple 2D problems, but not 3D complex industrial problems like these. At that time, I got the inspiration and motivation to create CFD Baba channel, where I started teaching students how to deal with such complex problems. Not directly the complex problems, but the steps. So there are two parts. One is component level analysis and second is system level analysis. So I try to focus on the component level analysis, and then every CFD problem is different. So students can navigate their way and learn to do the full system problem from my component level simulation tutorials. So the student skills required are not one or two, they are a combination of many skills together. So we will talk today one by one on all these skills. So the very first skill is understanding the problem. So I mainly created this PPT to help Indian students who are trying to navigate their way into industry using OpenFOAM. But I don't see any students here. Also I see 40-50 participants, but we have good professors here. So please, if you find anything helpful, pass it on to your students. So the understanding the problem means how much 3D CAD model should you create in the software on which you want to simulate. Second, you need to know material properties, boundary conditions, and the physics or models or equations that you need to solve. So all these things must be clear even before you touch your computer. You also need to know what output you want from your simulation. And also I would say that CFD model is just a virtual model of the actual problem. So create your CFD model, try to create as close as possible to the real flow. And another thing, if there is any other alternative than CFD, then please use that method to solve industrial problems, because companies love it if you save some money. So it can be done using, by creating tools in Excel using empirical formulas and so on. So I wanted to show this one thing. I had created this simulation using a real life problem. So one day in bathroom I saw that the mug was rotating inside the bucket. It was very interesting to watch. So I thought maybe I can model it in CFD. So I opened OpenFOAM. I used Interform solver, and I was able to replicate the real world phenomenon into CFD world. So as you can see here, the vector arrows in the second video, simulated video, are also going round and round. That means the water in my simulation is also rotating. So try to find problems around your vicinity. Try to simulate them in OpenFOAM. That will help you build your portfolio, and it will help you become better engineer. So the next skill is CAD. So how many of you can create this simple 3D CAD if any software of your choice given to you? So from audience, many less people will be able to do it, I think, because we don't focus much on CAD aspect. But in industry, it is mandatory. You need to know basic operations like Boolean, extrude, revolve, blend, pattern. It is not even hard. It is very easy, but you should invest time at the right moment and learn these things. Also, if you are going for any new problem, don't directly go with 3D problem. Try to start with a 2D plane cut out from your 3D problem. Of course, it is not possible for all problems, but whenever it is possible, do it. In this case, on the left side, I have a 2D CAD model of a Santa Claus with reindeer. I simulated it in Christmas 2021 just for fun. This is simple foam, and we see that the reindeer at the very beginning has a lot of pressure on it, air pressure. Next, next we require cleanup skills, because in industry no one will assign you a dedicated design engineer. You have to do it yourself. You have to learn to modify the CAD that you receive from the customer. You should be able to remove unwanted parts and simplify the model to avoid complexities in meshing, which is our next step. So basic things again: perform all mesh quality checks, don't skip anything, don't think that it is okay if some quality check is failing, and also give systematic named selections, because it makes your work very easy in the solver setup part if you have systematic named selections. Also, for a new problem, start with a coarse mesh and see if solution is running. Don't directly start with fine mesh, because if you run it for hours and hours, later you come to know there is a small problem in boundary condition or something, all the hours are wasted. So that's why I try to use this approach. There is one wedge model in the extrude mesh dict of OpenFOAM. So this wedge model allows you to model only a part of your cylindrical geometry. So if your geometry is symmetric in cylindrical coordinates, please try to use the wedge model. You don't need to model the whole CAD. Just model a part of it and solve it, and it gives fairly accurate results. And when going for 2D mesh in OpenFOAM, if you see here, try to create only one cell in the third direction. Don't create more than one cell, because it is a waste of resources. And if you follow all these points, then one day even you will be able to mesh this complex lion. You see its nails have been captured in the mesh, its mane has been captured in the mesh. By the way, this is snappy hex mesh. And if snappy hex mesh can mesh such a complex line, then of course it can mesh the mechanical industrial parts easily, I think. Next is the solver setup part. So many times puzzling things can happen when you try to attempt new industry problems. So I am currently working in Cummins, India Limited, as a senior CFD engineer. So they use commercial tools only, but I am trying to bring in OpenFOAM into the company, and I have already placed the roots of OpenFOAM into Cummins. Last year I have simulated a simple geometry in Cummins, the Cummins geometry in OpenFOAM for flow analysis using simple foam. So now I leveled up the complexity this year. I took on actual problem which they solve in ANSYS Fluent and tried to do it in OpenFOAM. So there is this thing in my geometry, the flow is above 100 meters per second, very high velocity. And I am trying band simple foam because there is heat transfer involved. So the rho or density value explodes every time I try to run the simulation. And it stops with a negative initial temperature error. So if you face any such errors, always read and try to find the source of error. And the best thing I can recommend is CFD online forum. It contains lot of knowledge from years of OpenFOAM users where you can check. So I checked it. They said check the mesh. So I reduced the complexity of the problem, made it a simple pipe with varying diameter, but still it diverged. Then they said, check the boundary conditions. I tried with various boundary conditions, but still it is diverging. They said then bind simple foam is quite unstable. Try with the transient solver for a few steps and then switch to steady state solver again. But even that did not work. So currently I'm working on this problem. If any one of you has faced any such similar issue and overcome it successfully, then please reach out to me and I will be happy to discuss further on this problem. Next step is, the next skill, the main skill, post-processing. So you need to explain your results in simple language because most of the times the people who will take the decision won't be CFD people, they will be management people. So if you go into the intricate details of CFD, they won't really understand it. So explain properly with as many images and also variable plots as possible. That will give a better picture of your problem and solution. So a tip would be you can display CAD and multiple variables, like in this simulation of Ahmed body. I am showing the CAD model, I am showing the mesh, I am showing the pressure values on the mesh grids, and I am also showing the velocity vectors, the velocity streamlines. So it is showing 4 things in a single image. Even in this video here, I am showing the walls of the Pelton. This is Pelton turbine. Walls of Pelton turbine are pressure colored. There is velocity streamline and geometry is also seen. It was dynamic meshing. So what happens after, suppose if you learn all these skills, then what happens? So if you want to go in application side, you should have command on CFD tools. If you want to go on development side, you need to know CFD tools and coding and also mathematics. So the thing I would suggest is that create a good portfolio. It can be done in form of PPT. Choose your best complex problems and do at least 20 problems hands-on to fill your portfolio, because your portfolio will speak louder than your words. And once you will come to know in which domain you want to enter for your job, then once you finalize your domain, make it domain expertise, because if you don't have domain expertise, people won't prefer you in industry. They want people who can simulate and give end-to-end solutions for their problem. So there are multiple streams, turbulence models, porous medium, heat transfer, heat sources, multi-phase combustion, and we also have LinkedIn, where you can go and approach CFD professionals after you learn these skills. But then you will ask, how do we do 20 problems and best complex problems if we don't have a job? So you can start with CFD model from research papers. Research papers are your best companions right now to enter into the CFD world. So try to find CAD model, material properties and boundary condition from research papers and simulate them yourselves in OpenFOAM, because it doesn't cost money. So I'm thankful to all FOSSEE members for this opportunity, and I'm trying to encourage and implement usage of OpenFOAM in Indian CFD industry. And I think so today I saw that the vision of FOSSEE and what I'm doing is almost similar. So we can join forces and we can achieve this with the help of FOSSEE. So from CFD Baba side, I am ready to offer all the help that is needed to achieve this goal and to collaborate with FOSSEE. So here is a link to some of my tutorials. So all the models that I mentioned above are there in these tutorials. You can check them out on Udemy under the name of CFD Baba. More than 4,000 students have enrolled worldwide, and most of the students are from India, Turkey, and Egypt. So the best way and the most secure way to contact me is my email ID cfdbaba@gmail.com. I also have my website where I have uploaded some CFD courses. I have my YouTube channel with more than 500K views, just CFD content, nothing else. No shorts, only long form. And I have some followers on LinkedIn. I am active on LinkedIn, Facebook, and Instagram as well. So there was this small case study where I simulated. So I got this project from Libya. I simulated a Sabartha platform topmost level where you can see this heli deck. So the problem was that there were 4 points: north crane, south crane, racking board, and heli deck. People used to work there most of the times. Now what happens? This is oil mining rig. So this platform mines oil and harmful gases are emitted from these exhausts. So if SO2 ppm coming out from these exhaust gases is more than 5, people might faint or even die. It is very harmful for people. So we did this simulation and found out that the SO2 ppm levels were under acceptance criteria for all these points, and it was safe to work on them. So if you take CFD seriously, it can even matter for human lives. This is just one simulation, but we had to simulate wind flowing from all the directions. This is just wind flowing from heli deck side. So thank you for listening patiently. In the end, I would just like to say, if you want to become an OpenFOAM hero, you need to start from zero. Thank you.
Yeah, thank you so much. The ending dialogue was really good. Okay, thank you so much.